Alright, so this will be the key for your quiz that I gave back last week. To start off, the first question asked you for a continuous, so that's important. Has to be continuous, and it has to go through this one point. So what I'm going to start out with is the fact that this point has to happen. Now, if this is the, if this is the derivative graph, sign chart, then I know that at x equal to -4, there's a horizontal tangent. There's a horizontal tangent here, one here. I know the function is increasing here. I know the function's decreasing here, decreasing again, and then increasing. So you all actually have different answers. It's a matter of making sure that your answers match that sign chart. So -3 is right here. That would be about -3. So I'm actually going to increase until -4. I'm going to decrease, that's probably not the best. Let's go a little lower. Here's my horizontal tangent. I'm going to decrease until I get to -1. Should be here, horizontal tangent, and then I'm going to decrease some more until I get to 3, and I'm going to increase after. So for those of you that had test A, it looked like this, and I believe test B you would actually do it kind of backwards, I think, in a sense. I'll do that in blue. So what you guys had were negative, positive, positive, negative. So same point, and in blue I think you had to, not that point. I believe the point was this one right here. Sorry about that. So I decreased till I got to a horizontal tangent, and then I increased. So this point right here, let me actually get rid of it. That's still supposed to be from graph number 1. So that was that horizontal tangent. Alright, so here we go. In blue, I would need to decrease till I got to a horizontal tangent there, and then I increase to the point -3, but I keep increasing until I hit -1, and then I keep increasing, and then let me try this again. Let me try to not go up so high. Alright, so I'm increasing until -1. I flatten out, I increase some more, and then when I hit 3, I flatten out and come back down. So this will be horizontal tangent here, horizontal tangent here. So those would be the two answers for the first problem. Number 2, I asked you to create a sign chart for each of them. So this is the sign chart I wanted. So if I want f prime to get from here to here, I would look at slopes. So if I'm looking at slopes, I have a horizontal tangent about here, here, and here. So, keep doing that. Sorry, guys. There we go. Alright, so my horizontal tangent here, here, and here. This is A, this is B, 0, 0, and then in terms of my slopes are positive, and then my slopes are negative. So now I need to do the graphs below. So that would be the top graph. I'm actually going to erase this and pull this up. There you go. So we're going to create sign charts for each of these, and below are all graphs of f prime, and if I want to make f prime sign chart, I'd be using y values. So if you got this problem wrong, either you didn't pay attention to the directions, and the directions were to make a sign chart for each of them, or you didn't pay attention to the fact that the graphs down here are all f prime graphs. So I'm looking at y values. So now I'm looking at x-intercepts that are 0. My graph is above the x-axis, below the x-axis. Y-intercepts again, x-intercepts. And then I'm below the x-axis and then above. Over here, I stay above the x-axis all the time. This one, I'm above, below, above, and then finally here, 0, I'm below and then above. And then the answer to the question, I believe, If you look at the sign charts and where the zeros should be, I think the answer was A. I actually can't remember off the top of my head. All right. Evaluate the limit. So, change up the color a bit. It's getting a little boring with that blue. The limit as x goes to a of f of x, which is given, minus f of a all over x minus a. So then I need to multiply this one by 3 minus a over 3 minus a. And then this one by 3 minus x over 3 minus x. Alright, so next step here, let's go to the right, would be, and I think I moved it again, there we go, the limit as x goes to a, and then, so the numerator would be this part first, right here. So I'm going to actually write the 4 in front, and then the 3 minus a, and then the minus sign, and then this guy, 4 times 3 minus x, see, all over the common denominator, which are both 3 minus a and then a 3 minus x. Alright, don't forget about that x minus a, so I'm going to multiply by 1 over x minus a. And then now, let's do step by step here. Limit as x goes to a. I have 4 times 3, which is 12. Well, actually, let's do it a different way. Let's factor the 4 out. So I would have 3 minus a minus 3 minus x all over 3 minus a times 3 minus x multiplied by, which is the same thing as dividing also by x minus a. That might actually help us save a little bit of time. So I get that the limit as x goes to a of 4 times, so negative, positive, I think the 3's cancel, and I end up with x minus a inside, all over the denominator, which is 3 minus a times 3 minus x times x minus a. Those can cancel. And then we go to the limit, oopsie, as x goes to a. We got 4 over 3 minus a times 3 minus x. And then now that I simplified it, what you were trying to do this whole time was simplify it so that this was gone. You wanted that to simplify out, and that happened in this step. That's how I know now I can substitute in as x goes to a. So this x here turns into an a, and we end up with 4 over 3 minus a whole thing squared. Alright? Number 4, write the equation of the normal line. And actually, let me just double check I did everything I needed to. Sorry about this little guy. Alright, write the equation of the normal line. So you have to know your definition. So this piece here tells me it's the definition of f primed of a, but notice there's no a, and now there's a 1. So now I know that this number is f primed of 1. This here is the point that they're giving you, and that means it's 1, 1, 6. So, equation of the normal line would look something like this. The slope was negative 3/5, but the derivative gives you the slope of the tangent. So the slope of the normal would be opposite reciprocal, and then x minus 1. Number 5, below is a graph of f of x on the same set of axes, graph f prime of x. So f prime is the slope, right? That's the easiest way to kind of say what the derivative is. So the word slope comes to mind. So if you look at this piece of the line, it goes up 1 over 2, up 1 over 2. So that guy's slope is 1/2. This one goes down 3 over 1, down 3 over 1, so this guy's slope is negative 3. I know right here that this is a corner, therefore the derivative can't exist there. So what does the derivative graph look like? Well, let's see, positive 1/2 would be about here. And then negative 3 would be about here. And that would be the graphs of the slope. Number 6, create a sign chart for f prime. So here's f prime. The graph I'm given is f of x, so I'm looking at slopes. So first I'm asking myself, where are my slopes 0? That'd be here, that's a horizontal tangent. That'd be here, that's a horizontal tangent. And that would be nowhere else, I don't believe. Then I also want to ask myself, and I'm going to put in the values, that's negative 3, that's positive 1. Then I'm going to ask myself, where are my slopes undefined? Well, slopes are undefined at discontinuities, at vertical tangents, at discontinuities, and at corners. Alright, so next piece is, when are my slopes positive? My slopes are positive when the graph goes up or increases. So increases here, decreases, 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 increases, increases, decreases. And it keeps on decreasing. Number 7, I want to show if f prime of 2 exists. So let's start with continuities definition. So I need the limit as x goes to 2 from the left. Having some trouble here. And that would be negative x squared plus 1. This is the left side, this is the right side, this is also the y value. Alright, so, and that gives me negative 4 plus 1, which is negative 3. I also need the limit as x goes to 2 from the right side. And that would be negative square root of 4x plus 1, which would be the negative square root of 9, which is negative 3. Then I also need the y value, which would be where the equal sign is. That's this guy. So it's actually the same as this. I'll rewrite it though. See? Just so you have it. And because the left, the right are equal, that means the limit as x goes to 2 of f of x has to also be negative 3. And then the y value is also the same. So really I was looking that you check the left, the right, and the y value. So the next piece would be trying to prove that the function is differentiable. So I'm going to actually use a new page here once I get there. Whoa, lordy. Alright. So, if you remember, we just found that f of 2 is equal to negative 3. Remember that? Okay, so a lot of you guys got this problem wrong, and the reason was when you were doing your limits, you forgot to do them from the left and right. So what I mean by that is most of you did this correctly. You wrote this, and then you also wrote you're doing 2 plus h minus f of 2 all over h. So if you didn't use the 2, I'm going to show you that also, but f of 2 plus h would be the left side, so that's this guy. So that would be negative 2 plus h squared plus 1, and then minus f of 2, which is negative 3. And then that whole thing over h, and I'm squeezing my limit back in because I forgot it. Alright. Alright. So, that's what it looks like if you actually use the x value. If you don't, and I'll do it right underneath. If you forgot and said, oh, I forgot to use the actual x value, the left looks like this. So it would be negative x plus h squared plus 1 minus, and here's where you made the mistake. You see that equal sign? This is the right side, but it's also the y value. And what that means is here where you're supposed to be finding f of x, that's this pink piece right here, you would have to use this function. Oopsie, f of x, that was supposed to be not x plus h, sorry. So f of x really does look like, let me get rid of that extra parenthesis, I don't need it. You would use this function for f of x. but then all over h. Okay? But if you're doing the right side, that one, because this is the right side and the y value, whether you do it using the value of 2, which is the smarter way to do this problem, I would have negative square root of 4 times 2 plus h plus 1 minus the negative square root of 4 times, oh, no, not 4 times, sorry. I can actually do f of 2, which is right here, negative 3, all over h. If you go back to the videos, you go back to the notes, you go back to everything that I gave you, we talked about the fact that this negative 3 back here will be the same because it comes from the y value, which is circled right here. It's the front part that'll be different. So with numbers, it's easy to do. What I noticed is a lot of you disregarded the fact that I told you that substituting the number in will be easier, and you tried to do it with the function. So I'm going to show you what that looks like here. That would be negative square root of 4 times x plus h plus 1 minus the negative square root of 4x plus 1 all over h. So what made a lot of you get this problem wrong is forgetting that this in the back where it says f of x or f of 2, that has to be the same whether you're doing the left-sided limit or the right-sided limit. And that's probably the piece that most people got incorrect. What I'm going to do is continue on using the evaluated ones at x equal to 2. That means I'm actually going to delete this part right here so it's not in my way. And this part right here. So, going back to where we were, the limit as h goes to 0 from the left would be negative 4 plus, where am I getting this? Right here, plus 4h plus h squared plus 1 plus 4 all over h. Limit as h goes to 0 from the left, the negative 4 minus 4h minus h squared plus, see, I didn't mean to put a plus 4, that was supposed to be a plus 3, plus 4 all over h. So those cancel. I'm going to have the limit as h goes to 0 from the left of h times negative 4 minus h all over h cancels. And then this h is going to go to 0, and my answer on the left side is negative 4. On the right side, the limit as h goes to 0 from the right, you get negative square root of 8 plus 4h plus 1 plus 3 all over h. You get the limit, having a hard time writing that, as h goes to 0 from the right, of negative root of 4h plus 9 plus 3 all over h. I'm going to multiply numerator and denominator by negative 4h plus 9 minus 3 over negative 4h plus 9 minus 3. The numerator, it's taking forever, the numerator is this piece squared minus this piece squared. Remember how that works? So I get 4h plus 9 minus 9 all over h. Alright, so what do we get? Those cancel. 4h over h, those cancel, and I get 4 on this side. So they are not equal. So the answer to the question is that f prime of 2 does not exist. What's happening there? It is a corner, in case you were wondering. Alright. Number 8. Find where and type. So, I see even over odd, and when I see that, I think in my head, even over odd is a cusp. Where does it occur? Well, that belongs to this function, piece of the function. Let's see. So I get 4x plus 5 equals 0. X is equal to negative 5 over 4. So that's the location of the cusp. Letter B. This guy is a little bit different. For those of you that struggled with it, I did factor it. Factor, and you'll see that you get x minus 5. So, if you see that you kind of have the same function, you should realize that this will be that jump discontinuity graph. And so what you're doing is you're picking values around the jump. We know the jump's going to happen at 5. And so 6, if you put 6 into the, if you put 6 in, what do we get? We get negative 1 on top, divided by 4. But if I put 4 in, I get positive 1 over 4. And that's because the bottom gives you negative 4, but then you're going to take the absolute value of it, which gives you positive 4. So the graph of this looks like, at 5, the right side would be negative 1/4. So is that negative 1/4? And then positive 1/4 this way. So the discontinuity happens at x equal to 5. What type of discontinuity? It's a jump. Letter D, I must have skipped a letter. It must be hiding under there. Let's see. There it is. Alright, so this guy, we have odd over odd, which tells me I have a vertical tangent. Alright, so where does it happen? Same thing as before. You take who owns that power right here. 2 minus x, set it equal to 0, and I get that x is equal to 2. So vertical tangent at x equal to 2. Last one here. We have a lot of things going on. I have a potential jump. I don't know if it's a jump because I haven't checked it. And then I have this guy, which is very factorable. So I'm going to rewrite this as 4 times x minus 2 in the numerator. Denominator, I got a factor. Let's see. 6, 7. So, to start off, I know at x equal to positive 2, there's a removable discontinuity, which means it's not differentiable. At x equal to positive 1/3, I know there's an infinite discontinuity, which is not differentiable. And then the jump discontinuity, I have to check. So, at x equal to 4, I'm going to substitute. I'm actually going to use a simplified version for this guy, a little bit easier for me. So the left side limit would be 4 divided by 11, and then the right side limit would be 16 plus 5, which is 21. So there's definitely a jump discontinuity. Hopefully I did this part right. Alright, and that's everything. So there is your test.